NASA is looking for dangerous asteroids. Io is blasting lava into space. The solar wind could be creating water on the moon, and space power is finally getting a test. All this and more in this week's episode of Space Bites. The more we learn about space and look at the various objects around the solar system, the more we learn that we are in a cosmic shooting gallery. Just think about what happened to the dinosaurs 65 million years ago. We see meteor crater. We know that asteroids can and do strike the Earth. It's not a question of if, it's a matter of when. And so it makes sense to try and find all of the dangerous asteroids that are out there. And astronomers have been doing this for several decades, charting most of the planet-killing asteroids, the ones that could take out a hemisphere. But there are still a lot of very dangerous asteroids that are in the city killer range, regional destruction, and a lot of those still, we have no idea where they are. And so NASA is planning a new mission called the Near Earth Object Surveyor, or NEO Surveyor. And this mission has been in the planning stages for more than a decade. But with the success of DART and with just more and more close encounters with asteroids, I think NASA is really getting serious about charting the location of all of these potentially dangerous asteroids. So what the mission is going to do is it's going to fly, launching in 2028. It's going to go to the Earth-Sun L1 Lagrange point, so on the other side of the Earth from where James Webb is. It's going to loiter there and use a very special kind of infrared telescope that will allow it to see asteroids, even if they're jet black. They'll still be radiating some heat, reflected sunlight from the sun, and they will give off this infrared signature. One interesting technology is that the NEO Surveyor will have a sun shield similar to James Webb. This will allow it to keep its telescope and instrument very cold, and this will allow it to see these really cold objects in the infrared spectrum. And the hope is that with NEO Surveyor, which is not at Earth, it's able to see objects that would be normally in Earth's blind spot. It'll allow them to chart all the rest of the most dangerous asteroids and help figure out, are there any in some kind of dangerous trajectory we could have them hit Earth at some time in the future. So this is great news. This mission will protect Earth, and when you layer on the success of the DART mission, that we now have the ability to reach out and smash an asteroid that could be dangerous, it's feeling like we're about to be able to decrease one of the existential risks that humanity faces, which is kind of cool. Io is having a major volcanic outburst. Last summer, Jupiter's moon Io blasted out an enormous eruption of lava off the surface and into space around the moon. And this huge volcanic outburst was actually visible from a fairly small telescope here on Earth. The telescope is called the Io Input-Output, or Io-Io. And it is staring as much as it can at the region around Jupiter. It has a coronagraph, sort of in the way that various telescopes can block the light from stars. But in the case of Io-Io, its coronagraph blocks the light from Jupiter. And this allows it to reveal the faint effects of its moon Io in the surroundings. And this is a very large volcanic outburst. Io doesn't have a lot of gravity, and so when it does erupt this lava, which is doing all of the time, Io is the most volcanic place in the solar system, this stuff goes into escape velocity. So instead of falling back down on the surface, some of it can actually go into orbit around Jupiter. And so you get this major outburst. One of the cool things about this story was that this telescope is actually a fairly modest. You could go to a telescope shop and buy the kind of gear that made these kind of observations. And so it shows that with some ingenuity and a very specific set of instruments, you can make these really cool observations of various things that are happening in the universe without launching a $10 billion space telescope. We're going to get some more views of Io when NASA's Juno mission is going to make some close flybys of the moon. Its next flyby is going to be in December 2023, and then it's going to do another flyby in February 2024. It's going to come within 1,500 kilometers of the surface of Io. And this is the closest we've been since the Galileo mission was there in the early 2000s. So it's been a long time since we have had a nice close-up image of Io. I'm really looking forward to this. The solar wind might create water on the moon. We've known that there's been water on the moon for quite a few years now. It was actually first discovered by India's Chandrayaan mission, which was able to detect the presence of water coming from the surface of the moon. And that was later confirmed by NASA's SOFIA mission. And of course, we talked about SOFIA with the end of the year wrap-up episode that we did, where that was one of the big stories of the year. And SOFIA has an infrared telescope that allow it to be able to sense the presence of water, and not just at the permanently shadowed craters at the south pole of the moon, where it's believed they're like really vast deposits. No, this water is everywhere around on the surface of the moon. It's not a lot. Like if you dug up 1 cubic meter of lunar regolith, you'd get about a water bottle's worth of water out of it. So it's not much. But the question is like, how did it get there? And so one idea is that water got there from comets and it just hasn't been completely vaporized by the solar radiation. But this other idea is that the water is created in place by the solar wind. Like the solar wind is largely made of protons, hydrogen. And so when these hydrogen atoms strike the moon, they've got enough energy, they can break apart other molecules, and the hydrogen can find its way to oxygen, and this produces water. And we got a confirmation that this is actually happening thanks to China's Chang'e 5 mission, which was the one that brought the sample back from the moon. Researchers in China were able to examine the water in the regolith that they returned from the moon, and they were able to see that actually the kind of water, the hydrogen versus the deuterium, the flavor of the water, the fact that it has a hydrogen to oxygen mix different from a deuterium mix, matches the presence of the solar wind. And so they were able to tie together that the solar wind is impacting the moon and it's creating water molecules. Structures on the moon could be built with microwaves. And when humans do go back to the moon, they're going to need someplace to live. And obviously it makes the most sense to build your structures, your roads, your landing pads out of this lunar regolith that's everywhere. But the problem is like you've got the raw material, you've got all this pulverized rock, but how do you cement it together? You need some kind of binding agent. And this has been one of the big challenges that a lot of engineers are trying to figure out. They take this simulated lunar regolith and then they just try different ideas to be able to bind this stuff together. And in some cases you have to bring something from Earth that you can use to then mix in with the regolith that you can then harden it, kind of like concrete. But a new idea is that you actually can make hardened structures on the moon without needing to bring something from Earth. You just have to bring a very powerful microwave oven. In the regolith, about 1 to 2% is a very highly magnetic mineral. And by blasting this mineral with microwaves, you can cause the regolith to sinter together, to kind of glue itself together. And one of the other cool ideas is that you can actually use magnets on the moon to separate out this more highly magnetic stuff. You can actually purify the regolith so that you get a stronger and stronger bond between the various molecules that are on the moon. And so you can imagine in the future, they'll lay out where their road is going to be or where their landing pad is going to be, and then they'll just hit it with a really powerful microwave beam bit by bit by bit and solidify this regolith so that now you've got a landing pad, now you've got a road, now you've got a building. It's a really cool idea. Now, obviously people have been trying to figure out ways to harden lunar regolith for a long time. I'm sure there's some technical paper in the 1960s from NASA proposing a way to do this. But you bake it in ovens, try and figure out ways to heat it up. But this is just like this ongoing process of research. It's a very refined method that should be very effective and not require a lot of additional inputs from Earth and not a lot of complex machinery and structures, just some way to be able to hit the regolith with a concentrated beam of microwave. How to navigate on the moon. We always know where we are here on Earth thanks to the global positioning system. This is this network of satellites that fly overhead. They use very accurate clocks to tell us where you are on Earth at any point. But when astronauts and rovers go to the moon, there's no GPS system on the moon. You can't use the one from Earth. Like the transmission times from Earth to the moon are too long. But there's a really clever idea for how you could navigate on the moon. This came from some NASA engineers. And what they did was they fed in all of the imagery from NASA's Lunar Reconnaissance Orbiter mission, which has mapped out the topology and all the craters and all the mountains on the moon. And then they were able to simulate what it would look like being at a spot on the surface of the moon. Imagine you could sit there and look around and see all the landmarks, see all the mountains and craters and various large boulders around you. It's a very unique fingerprint to a very specific location on the moon. And what they were able to find is that if you feed in all that data, you can then simulate, and then you can take a picture, a 360-degree picture of any place that you are, and then map that and figure out precisely where you are on the moon without needing to communicate to the sky. It's something we kind of do here on Earth, right? You're walking along a road, you recognize various landmarks around you, you know where you are. And we could be able to do that, or at least a computer could do that for us when we go to the moon. So it's kind of like that game GeoGuessr. You know, if you go and look at some spot on Google Street Maps, try and figure out where you are on Earth, but the computer is geoguessing where it is on the moon. And computers are really good at that kind of thing. All right, take a look at this picture of the Earth rising above the lunar surface. This is beautiful. This picture was taken by South Korea's Danuri orbiter, which is currently at the moon. Now, the mission launched back in August 2022 on a SpaceX rocket, and it entered lunar orbit about a month ago and is now orbiting around the moon about an altitude of 120 kilometers, and it goes once around the moon every 2 hours. And the purpose of the mission, like, this is South Korea's first mission to the moon. And the purpose of this mission is to map out the surface of the moon to prepare the way for an upcoming lander that's going to be coming from South Korea probably in 2032. But I just really love this picture. It's only in black and white. It's not a nice color picture, but still, you can just really get a sense of the Earth rising above the surface of the moon. I really like it. I've mentioned this before, but we really try to minimize the amount of advertising that we do on our various channels. There's the minimum possible ads here on YouTube. We don't have any long sponsorship agreements. And this is thanks in part to our Patreon club. This is all of the members who support us every month to help create the work that we do. And one of the goals of Universe Today, and maybe this is an impossible dream, but I would love for us to get to a point where we are mostly funded by the patrons. Like, imagine the situation where we create space news content for the fans, that we're not trying to think about what the advertisers want. We're not there yet, but we're getting closer. And if you think that the work that we do is important, if you think it's a laudable goal, then why don't you consider joining our group of patrons? And if you do, we'll remove all the ads from all of the media for you. You get access to some of our videos in advance. You'll lose all of the ads off the Universe Today website for life. Even if you stop being a patron, you'll never see another ad on Universe Today ever again. So go to patreon.com/Universe Today to join our community. Thanks. China is planning a lunar station. Now, I've mentioned many times in the past that China is planning to send humans to the moon, and not just footprints and then bringing people back, but they want to permanently have a station on the moon. Sort of think of like an Antarctic research station, but on the moon. And this has been their primary plan. If you look at the logo of their various missions to the moon, it is the moon with a human footstep. They're going to the moon. And we've seen now 5 missions go to the moon, the Chang'e series. The most recent one, Chang'e 5, was the one that brought those samples back from the moon. So Chang'e 6 is going to be another sample return mission. And it's going to be followed by Chang'e 7, which will be surveying the polar region of the moon. And then Chang'e 8 is going to be testing out various technologies that will be used by a research station in the future. And China said that their goal is they want it to be an international research station. So it's not going to just be them, but hopefully it'll be other nations that'll be participating in this. And we don't really know when this is going to happen. Probably in the early 2030s, I would assume. So we'll obviously be keeping you posted as there are new updates to their missions. And when we finally get a date when they're planning to send those first humans to the moon. I think a lot of people feel like this is a race. And like, maybe it's a race, but I think it's really exciting to have multiple groups going to the moon to bring humanity more permanently into space itself. I think this is what our science fiction books told us that we would inevitably be doing, and it feels amazing to be watching as all of these steps come together, both from NASA, SpaceX, Chinese, and other nations and collaborations are sending humans permanently to the moon. Finally, a test of space power. One way to generate electricity down here on Earth is to use solar panels. And of course, there's a few giant flaws to solar panels. They don't work at night. They're not great when it's cloudy. So wouldn't it be cool if you could harvest your solar energy from space and then send it back to Earth? And of course, this idea of space power, this has been suggested and proposed for decades. Again, it's probably in some technical document by NASA in the 1960s, but finally, a mission has actually gone to space that's going to try to test this out. And there's a couple of technologies that it's going to be testing while it's in space. The first part is the harvesting. It's got a bunch of solar panels on board that it will use to harvest solar energy and then convert that into electricity. And then the second part is the microwave, which will take the energy and transmit it down to a ground station on Earth to find out, like, how efficient is this process? And I've gone on record in the past saying that space power is not very efficient. And when you add in the fact that you have to send a spacecraft to be able to harvest this solar energy, solar panels look pretty cheap, even with their downsides. But there are places on Earth and places in space where it's actually really hard to get power. And so by testing out this technology, we could get to a point where, for example, you could have a base on the moon that's in one of the permanently shattered craters, and you've got solar power satellites flying overhead that are beaming power down to the station without it needing to be able to collect sunlight on its own. So there's a lot of interesting applications. And I actually did an interview with Dr. Stephen Sweeney about space power and these other ways that you could use space power in space, as opposed to the sort of this traditional idea of trying to beam it back down to Earth, which isn't that efficient. All right, those were all the news stories for today. Of course, we've got links to everything I talked about today down in the show notes down below. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 55,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Tim Whalen, Dave Verabioff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. All right, that was all the news for today. We'll see you next week.